This is number 14 on your 5, 3, and 5, 4 chapter review for your quiz tomorrow. And it wants you to solve for x. So the problem is cosine of x equals sine of x divided by 2. Well, the first thing that should be going through your head is an alarm because I have that sine of x divided by 2. I'd rather have this just be x. So I can take one of the trig formulas I've learned, the half angle identities. We have one that says sine of u over 2 is equal to plus or minus the square root of 1 minus cosine of u divided by 2. And the plus or minus just comes from, okay, well, what quadrant are we going to be in? Because we can't get a negative out of a radical. So I'm going to replace my sine of u, my sine of x over 2 with this formula. But instead of u, I'll have x. So that'll make my new equation cosine of x is equal to plus or minus, because I don't know what quadrant x divided by 2 is in, the square root of 1 minus cosine of x divided by 2. Now I want to solve for x. Now that I don't have that whole x divided by 2 as my actual angle. So the first thing I'm going to do is have to get rid of the square root. So I'm going to go ahead and get rid of square root. I'm going to square both sides. So then I'll end up with cosine squared of x equals, now no matter what, this plus or minus doesn't matter anymore because when I square something, a negative times a negative makes a positive, and so does a positive times a positive. And then the radicals canceled out, so I'm going to be left with 1 minus cosine of x over 2. Now I want to solve for x, so I got to get x to the same side. So in order to do that, I first have to get rid of this divided by 2. So I'm going to times by 2. Anything I do to one side, do to the other. So I'm going to be left with 2 cosine squared x equals 1 minus cosine of x. I want to get the x's to the same side. And me being more advanced in math and being able to do it for so long, I already noticed I'm going to have a squared and a regular. So it's going to end up being quadratic. So I'm going to move everything over. So I'm going to end up with 2 cosine squared x plus cosine of x minus 1 equals 0. This is just a quadratic in disguise. Some of you can factor this with cosine in it. Others have a really hard time because of the word cosine. So if you're one of those people who has a really hard time with cosine, you can go ahead and do u substitution and say u is equal to cosine of x. But you have to tell me that. Tell me what you're replacing here. So then I'd get 2u squared plus u minus 1 equals 0. And if you're one of those people who don't need to do that, you could factor like normal. But now I'm going to factor. So I need something that multiplies up to negative 2 but adds up to 1. So I'm going to rewrite that as 2u plus 2u minus u minus 1 equals 0. Because then those equal that. I'm going to factor by grouping. Take out a 2u, I'd be left with u plus 1. Take out a negative 1, u plus 1. And then I'd get 2u minus 1, u plus 1. So then I'd get 2u minus 1 equals 0, u plus 1 equals 0. I'm going to skip some algebra here. U equals 1/2, and u equals negative 1. Now, this is why I don't like u substitution, because people generally forget I plugged something in for u, so now I got to take it back in and plug it out. So I know that u is equal to cosine of x, so then I'm going to get cosine of x equals 1/2, and cosine of x equals negative 1. Okay? Now, you could have avoided all of this if you just couldn't factor with cosine being in there, but this is what you do if it's u substitution. Get all the way down, solve it, and then plug back in what you had for u. So now I have to think on my unit circle. Cosine of 1/2, well, cosine is my x value on the unit circle, so I know my x value needs to be positive, so it's going to be here and here. The angle that gives me an x value of 1/2 is actually pi over 3. So I know x is equal to pi over 3. But then I also have another, remember, because all this means is my x value has to be between, or has to be positive. So I have another one on my unit circle. it's just the reflection of it, and that is actually slightly less than 2 pi, so it's going to be 5 pi over 3. And I have to go back and solve this one. I want where my x value is negative 1, because that's what cosine stands for, is my x value. Well, I get an x value of negative 1 here, which is at my angle pi, so I get pi. Now, just like when we were solving normal equations, because I got rid of that whole square root factor, I opened the door to having extra answers, some ambiguous, some what we call extraneous solutions. So I need to make sure all of these work. So I'm just going to go ahead and plug them back in. So I get cosine of pi over 3 equals sine of pi over 3 divided by 2, which is sine of pi over 6. So I just want to make sure those work. I know cosine of pi over 3 is 1/2. And sine of pi over 6 is also 1/2. That one worked. So pi over 3 worked. That one's good. Check cosine of 5 pi over 3 and sine of 5 pi over 3 divided by 2. Well, I know this is still cosine of 5 pi over 3. Oops, sorry. This becomes sine of 5 pi over 6. Cosine of 5 pi over 3. Well, that's in this quadrant, so that's 1/2. And then sine of 5 pi over 6 is over in this quadrant. It is also 1/2. That one works. So then got to check my pi. So I get cosine of pi is equal to cosine, or no, it's not, is equal to sine of pi divided by 2, because I'm just plugging it into my original equation up here. I know cosine of pi is negative 1. Sine of pi over 2, though, is 1. Those are not equal, so that one doesn't work. And remember, the only reason we had to check for extraneous solutions, because anytime we square a radical, we get rid of answers that might not possibly work. Because if we plug that in here, we'd end up getting an answer that doesn't quite work. So your only answers for this are pi over 3 and 5 pi over 3. And that is how you do number 14.